The automation of road vehicles is one of the greatest and most complex engineering challenges of our time. Solving it requires thousands of scientists and engineers worldwide. Through a combined effort, it is possible to make traffic safer and more efficient, to make mobility accessible to more people, and to allow passengers to do more exciting things than turning wheels and pushing pedals. If we want to make this vision a reality, many open challenges still need to be solved. Join our course for an introduction to these challenges and for a step-by-step guide to start working on them. How can vehicles perceive and understand their environment? What methods can be used to predict road users' actions? How can vehicles plan safe behavior? What role does the cloud, 5G and vehicle-to-everything communication play? Find out in this MOOC on automated and connected driving challenges how you can contribute to answering these questions. Bastian Lamper is the group leader for function development in the department Vehicle Intelligence and Automated Driving at the Institute for Automotive Engineering of RWTH Aachen University. He will guide you through the lectures and exercises of the ACDC MOOC.
In our course, you will acquire essential skills that enable you to start working on current challenges in automated and connected driving. We will teach you how to use powerful tools such as the robot operating system, deep learning, neural networks and more. In our programming exercises, we will provide you with a software development environment where you can design, implement and test your own automated driving functions.
This course is presented to you by one of Europe's leading professors for automotive engineering, Lutz Eckstein, Director of the Institute for Automotive Engineering at RWTH Aachen University.
If you want to make automated and connected mobility reality, please join our ACDC MOOC. Together, we can shape intelligent mobility systems of the future.
Join the MOOC Automated and Connected Driving Challenges on edX now.